When you are writing code, are you doing it right? That's the question that worries a lot of people, and should probably at least be something that every developer thinks through. Design patterns are best practice concepts that we can implement into our code to make it better in some way. Think of them as guardrails that keep our code safe. In today's video, we're going to look at the first entry in the famous SOLID principle. That S stands for Single Responsibility Principle. We're going to dive into what that means, how it should change our programming practices, and how far we should take it. For those of you who don't know me, my name is Tim Corey, and it's my goal to clear up the confusion and frustration around learning C#, because learning software development shouldn't be so hard. If that sounds like something that would interest you, I think you'd benefit from subscribing to my channel. You'd probably also benefit from joining my mailing list, where you'll get exclusive content and insider access. That link is in the description below. So let's start the conversation on the Single Responsibility Principle, which we'll call SRP from now on, by looking at some code. I could do a nifty PowerPoint for you and show you fun pictures that try to represent this issue, but I find it best to look at this in a practical manner. Here I have a project I created in Visual Studio in C#. Now, the principles of this video will actually apply to any software development language. But since this channel focuses primarily on C#, that's the language we'll use. The code I have here is rather simple. I have a console application that asks for a user's first and last name. It validates both names. It then generates a username for that user. Pretty simple stuff. The problem with this application is that it violates SRP. So now we have some code in front of us. Let's talk about SRP. SRP states that a class should only have one responsibility. Or another way of putting that is that it should only have one reason to change. In this code, if we decide to change how we talk to the user to welcome them or to tell them we're done, we have to change the class. We also have to change the same class if we need to change how we capture the first and last name. If we decide to change how we validate names, this class has to change. And if we decide to change how we generate usernames, again, this class has to change. See all the different changes that could affect this class? SRP says there should only be one reason to change per class. Let's look at how we could do that, and then we'll discuss the limitations of SRP and how we can apply it to more than just classes. Let's start with a standard message we show the user. Right here we have console.writeLine, welcome to my application, which is pretty standard, it's pretty simple stuff. And since we're using a console application, that's how you print it out. That's great. But again, if we have to make a change to this, that's probably the only change we should make to this class, which we know we have other things to do. The other thing is we have return statement here, a return statement here, both with console readline beforehand, and then just a console readline at the end. That's really another message, a standard message to the user. Think about it this way. What if I said, you know what? It doesn't make sense just to have a console readline, that blinking cursor. Let's do a console.write first that says press the enter key to continue or to close, and then dot, dot, dot. Well, I need to add that before this line, and before this line. And again, I am now changing this program.cs file again. So the first thing we should probably do is look at seeing if we can't eliminate just standard messages. Now this is going to get a little tricky here, and I want you to at least take the SRP principle and think it through. Because that's really what design patterns are meant to do, to get you to think about your code. So if we follow SRP to its full conclusion, that a class should only change for one reason, it would make sense that we'd have a welcome message class and a I'm done class or a closeout class or something like that, because each of these messages is different. That seems to me to be overkill. And again, this is going to be where it comes down to these are principles, not requirements. Okay, so these are principles. You have to figure out how, in your best effort, to apply these principles to your code. So what I would do is I would probably create a new class, and I would call this class something like standard messages. And these would be standard messages that we give the user. Let's make it public. And I would create a standard message for the welcome message. So public, and I'll create static. Later on in our solid principles, we'll see how we don't necessarily want to use static here. Maybe want to use a full class instance. But until I get to especially the dependency inversion, I don't want to cover that yet. And so static is fine. And so if you're looking at this and you've already kind of gone through the solid principles, you look at this and go, well, there's more you can do here. And yes, there is. But I want to cover one thing at a time instead of trying to kind of pile them all together. Because, and you'll find this out as we go, the solid principles and other design patterns kind of all blend together. And they really work best when you don't just implement one, but you implement multiple or most of them. So, but for now, we're just going to create a public static method, and we'll call that just public static void, and we'll depend on the console. And that's one of those things, again, where we could totally abstract it from the console, but for this demo, for SRP, we're going to rely on the console. So we'll just say our welcome message. Like so. So this is a public static void welcome message. And we'll just take this right here, the console.writeLine. That's what I'm saying about depending on the console. This method now depends on the console being available. Which, again, is okay for our application. But if I was abstracting this out, I might say, let's see if we can't break that dependency and have it just return this message, and then maybe have program.cs actually write it to the console. So, but for our purposes, this is okay. So that's all I did. I created a class with a public static void that just does our welcome application, and that's it. I'll create another method, public static void end application, where we'll say something like, let's start off with just the console.readline, and that's it. Because that's what we have right now. So here, instead of this, what we'll have is standard messages dot welcome message. And then down everywhere we have the console.readline, we'll have the standard messages dot end application. Oops. End application. And by console.readline, I don't mean where we're capturing information, just where we're saying that's the end of the application. So it's the end of the application there, and there. All right. So now we've started our abstraction. We've started our breakout, because now, and this is, again, this could be its own class and this could be its own class, but my definition for one single change would be a change in the messaging, the standard messaging. And so in that case, both of these methods would apply to that. And so I feel like it's okay to put it in this one class. If you feel differently, that's fine. You can break it into two. So I have now one class that does two different tasks, welcome message and end application, both around the standard messaging. Next, we have this section right here, where we are creating a user and then populating their first and last name. Well, that seems like it should be its own thing instead of being lumped in here with a static void main. So let's do this. Let's create a new class. New class. We'll call this person data capture. Guess what its job is going to be? Well, it's going to capture a person's data. And in fact, what we'll do is we'll have a public static person, which is the return type is person, and we'll say capture person. Or we can say public, it'd be person data capture dot, let's call this dot capture. There we go. And so its job is going to be to capture a person information and then return that information. So we'll actually cut all this out and paste it in here. And then we can just say return user. We create a person user right here. Now, normally what I do in this kind of case is I actually change this to output. That way we know this is what's coming back out. So if you didn't capture what I did there, let's go back to where it was. I'll show you. So it was user was the variable name, but I have user here, I have it here, I have it here, and I have it here. If I change it at the declaration to say output, and then I hit control dot, it says, would you like to rename user to output? And it shows me the different places that it will change user to now be output because I've changed that variable name. I say, yep, click on it. And now it's changed everywhere it said user to now output. That's one of those shortcut things that's really helpful in refactoring. If I want to change a variable, no problem. I just change it at the source and it intelligently changes it everywhere. That means if I had a user somewhere else, like here, it didn't change that user because that's out of scope of this variable. And so it's not the same user. So it's really intelligent that way. All right, so now I have a class called person data capture that does one thing. It captures a person. Okay, so when I have changes to say what information I capture, that's the single reason this class changes. Okay, that's it. So if I say, you know what, I want to ask for first name, I want to ask for given name, no problem, I change it right there. If I want to ask for last name, I want to ask for surname, same right there. Okay, so it will change it a couple different times, but all for the same purpose, for changing how we capture or what we capture. If we can capture email address now, we'll just add one more set of requests here on the next line down for email address. So now over here, we could say person user equals person data capture dot capture. We're going to capture a user. Now, next we have these validators. So we're validating, hey, the first name, is it null or white space? If it is, say you did not give us a valid first name, end the application. Well, we don't want to do validation here as well, so we need to also extract that out into its own class. So let's do this. Let's create a new class, and we'll call this class the person validator. Because again, I'm going to put a couple of different methods in here where I'm going to validate, or it's going to validate two different things. I'm going to validate the first name and I'm going to validate the last name. And so the question is, do I create a method for validate first name and another one for validate last name? I don't think so. But I think that then the main would have to call both. And now we're tying the main to changing if we also have now email address. And so that doesn't seem like it's a good idea. And so instead what I'd probably do is I'd probably create a public static, let's call it bool, validate person. Actually, let's call it as validate, because the name of the class is person validator. So I'll do person validator dot validate, and we'll pass in that person object. Let's call it person. Okay, so you have a validate message that should return a Boolean. That Boolean will be yes, it worked, no, it didn't, or yes, it's valid, no, it's not valid. And inside here, we're going to do this work here. Let's actually get a comment as well. We'll cut this out, and we'll paste it in here. So now it's person, not user, so we'll have to take care of that. This is not a refactor case right here. Now, right now, what we have is we have a check for first name, we have a check for last name, and both of them will give the standard message to end the application, but they both return, which in the case of our program.cs, our static void main, return actually closes the application. Here, return doesn't do that. And in fact, we have to return a Boolean. So what we'll do is we'll say return false, return false, or at the very end, return true. So what this is doing is it's saying if you get through all the checks and none of them stop you, then it's valid. But if you hit a check where it stops you, it's going to return false. So it'll show the standard message end application, and it will return false, meaning stop. Now, I'm not sure we want to keep this here because we have it now twice. We could do it once. So let's come back over to our program.cs and say bool is valid. Let's say is user valid equals person validator dot validate. We'll pass in a user object, and now it will tell us if they're valid. If is user valid equals false. Now, I could do is not, put an exclamation point in front or the bang character in front and not have to do this part. You can't do both, by the way. That'd be true. But if I did this, that works as well. The only difference is, especially if you're newer to C# or if you're reading through real quick, that's not quite as obvious. It kind of blends into the characters. So I tend not to do that. I tend to encourage you to actually explicitly say false. So it's very, very clear what's happening. You don't miss it accidentally. So is user valid equals false. So if it's false, then we could do this. Just return. That's all we have to do. Because we've already done the end application. But I think what I'd like to do instead is cut this out. And we'll take it out of here as well. I'll come back over here. And I'll allow my main to make that call instead. So I know it's more obvious here that it's ending the application. And the validator then doesn't have to know anything about where we are in the application. It doesn't know that we need to end it. Because maybe we just say, hey, it's not valid. Let's loop through again, ask for the information all over again versus ending the application. So I kind of like to get that out of here in the validate because validate should know about where we are in the application and get it back to main, whose sole job is to know where we're at in the process. Now, before we move on from this, the one other thing that I'm looking at and going, I don't like this really, is this console write line. You did not give us a valid first name, you did not give us a valid last name. This seems kind of like a standard message. And so I'll probably do, in fact I know I will do, go to standard messages and create a new one. Public static void display error validation error. I'll pass in the field name. So now we can do is go to the validator. I'm going to copy this. Come back over here to the standard messages. I'll paste it in, and then I will put the $sign in front, and then paste it in here like so, inside the curly braces. So now this message will say you did not give us a valid whatever name or field name you pass in. Back over here, we can say standard messages dot display validation error for first name. And that field name is the user-friendly field name, not the first name all crunched together. That reads better for programmers, not so much for users. So this is the last name. So if the last name fails, call a standard message for last name. Okay, so now again, this has only one reason to change, and that's if we change how we validate the person object. Now we're not quite done yet. If we go back to program.cs, we still have this create the username. So let's create another class. Let's call this class the account generator. Because, well, right now it does just one thing, or it will do one thing, which is create the username. I can see it doing other things as well, all around account generation. Still single responsibility, one thing is doing, but it may have multiple steps in that process, or multiple pieces of that process. So we'll create a public static, and this is a void, right? So we have there's the actual creation, but then we also have this message here. So the question is, do we create another standard message for this, or do we have it be specific because it really is account specific? And I think we create this message right inside the account generator. And the reason why is because it really is account specific, and it seems like the wrong place to put it inside a standard message, because standard messages are for things that could be used across the board. Welcome and goodbye or close messages, that's pretty standard. And so is a validation message, because it might be for a different object or different model. But with this, it's very specific to the account creation, and we're really simulating here. We're not actually creating an account, we're just kind of simulating the account was created. So let's just say account generator or create account is the name. So we'll pass in the person user. I'll call it user here because we're creating a user account. So that makes kind of sense. And in here, we're just going to do these two lines here. That's it. And again, this is just simulating creating the user account. So nothing different here. And now over here, we're going to do account generator dot create account. And that's it. Oh, we need to pass in the user. So user. There we go. So now we save this. If we run it, it's pretty standard. Still Tim, Corey, username is tcorey. It's really simple. And it says welcome to the application. It has a cursor at the end. Everything looks good. So that's the basics of SRP. Notice how now static void main, it really has one job, and that's just to control the flow. Do this, then do this, then do this, then do this. Now there's still a little bit of stuff in here that I'd love to change. Now, part of it is stuff that I'm ignoring because it's not part of the SRP. For example, we're newing up a user right here, and that's really tightly coupled. We're not doing anything with interfaces yet, which usually when you see SRP, you see interfaces all over the place. And we'll get to that, but that's really for another one of the design principles. You probably should do it here, but it doesn't strictly fall under SRP in my opinion, at least. Okay, so what we've done is we've turned main into just, it does one thing, and that is it kind of controls the flow of our application. We've broken out all these different parts into different classes. So now, if you want to know how do we capture user information, well, it's probably under the person data capture section. If you want to know how we validate a user, it's under person validator. If you want to know what standard messages we do, standard messages. So it really has broken our application apart into little bitty pieces. And the benefit here, there are a few benefits. One of them is when you go to make a change, you probably should know exactly where to go. Now, if you did poor naming, or if you have 1,000 of these classes with no folder structure, yeah, you're going to have some problems. But if you create some kind of folder structure in here that makes sense, then it should be really simple and know where to go. It's also a whole lot easier to read the code because welcome message, capture a user, validate a user. If it's not valid, end the application, create the account for this user, and the application. That's pretty readable and pretty understandable. So that's another benefit of this SRP. The other thing is when you come in here and change something, let's change a standard message. Each one of these methods has one line of code. Now, sometimes you'll have a little bit more. Maybe you'll have 10 lines of code, 20 lines of code. But in general, you'll have really small methods and really small classes. And so if you do, it's really not hard to review what's going on in the entire class, let alone just the method you need. So for example, end application. Right now it does one thing, read line. Well, you know what? Let's add that console.write, press enter to close. Now it's really simple. It's 2 lines of code. I still know what's going on with the end application. And when I run this, it doesn't matter if I give it bad data. That's not a valid first name. Press enter to close. Or if I give it good data, username is Tikori, press enter to close. Okay, I've now changed it everywhere, and I only had to change one class, and it's the class that talks about standard messaging, not the one that talks about validating users, or the one that creates the accounts, or any of these other things. I change it in one place for one purpose, and it changes everywhere. So it really is, it breaks your application apart, and it forces you to think about what one thing does. And the SRP really talks about classes. So and that's one of the things that I've tweaked it a little bit in the fact that we talk about classes, but in here in the standard messages, I say that one responsibility or one thing that's changing is any standard message. But you could go to the next level and say, we could have a standard welcome messages class, a standard end application messages class, and a standard display validation errors class. That's fine, you can do that. And that would maybe more fully implement SRP, but it does add 3 classes, each of which have 1 line, or in this case, 2 lines of code, of actual code. And so that is the balance. And so I hear, some people say, well, this creates a whole bunch of classes. And yes, it does. But I don't think that's a problem. For example, if I'm in program.cs, I don't care if I have 100 classes. If I say I need to figure out what validate does, I select it, I put my cursor there, I hit F12. Well, there's the message, or the method, and it has, looks like about 8-9 lines of code total. Pretty easy to read, pretty easy to understand, and I go right to it. If I want to go back to where I was, I can hit the back arrow up here. I'm back to program.cs. Really easy to navigate using IntelliSense. It's really easy to understand what's going on, and everything is just little chunks. It's a whole lot easier to understand a little chunk than is the whole application. So before you push back on this is, too many classes, I don't really think it's a valid argument. You have to come up with something more specific on that. It doesn't cost you any disk space really, and even if it does, we're talking about bytes of disk space versus our gigabyte hard drives. So that's not really a problem. It doesn't slow your application down in any way. And having this all broken apart does make it easier to read, which if it's easier to read, it's easier to debug. It's easier to have a new developer understand what's going on and contribute. And so there's a whole lot of speed benefits from a development standpoint. So I really don't see a problem with the extra classes. Now, sure, the other end of it is you can go excessive. And you can have thousands of classes that each do one little thing, and that causes bloat in your application. Absolutely. So my encouragement to you is find the balance that works for you. But one of the rule of thumb principles in here is if your class scrolls on your Visual Studio. So for example, even though I have a large font size for display, I don't have to scroll this. Now, technically the using statements, that might be an issue. I can take those off because none of them are being used. But for the actual class itself, so this right here, if this has to scroll, you've done something wrong. Or at least you need to think about it. Let's put it that way. So, and this is the biggest one. This is main, which is a quarterback, and so it probably should be a little bit longer, could be a little bit longer. But of any of your classes that you create, if they scroll off a screen, yeah, it's probably too big. So think that one through and kind of keep that back in your mind. But in general, if you can think through, does this do two things? Or do I have to change this class for two different reasons? And if the answer to either of those is yes, it does two different things, or yes, I have to change it for two different reasons, then split it apart. It will make your reading of the code faster, it will make your understanding of the code better, and it will also set you up for success down the road when we're talking about these other design principles or practices. So that's the SRP, single responsibility principle, in a nutshell. There's a whole lot more depth we could go into. We could talk about all the nuance and all the rest, but I really want to keep it at a practical level in a way that you can easily implement in your code. Now, if you have an existing code base, it's not going to be simple to just come in and change everything all at once. Obviously, I understand that, but do a little bit at a time. So make one little change, two little changes as you can to make it a little bit more in compliance with SRP. If you create new code, make it compliant with SRP. Okay? I love to hear what your thoughts are about this. I love to hear, what pitfalls you see or what problems you've run into in trying to implement SRP. So leave those comments down below. And also, I will distribute the source code as well. So it'll be on my blog. There'll be a link in the description down below. You can go to the blog and get the source code to play around with and kind of see and feel how I did things. One thing to note is over here, I would probably, even if this small application, I would probably create a folder structure for this just because even now it seems a little bit complicated. So I might create a folder for, say, person, where I have person data capture, and person validate. Maybe one for account information, where I have just the account generator, and one for messaging or something like that. So I might do something like that. I won't do it in this application because it's really outside the scope of what we're doing here, but it might be something to think through as you're creating your applications. Nice little folder structures to help compartmentalize and keep things together that kind of fit together. All right, so that's it for SRP. We will, in the next video, in this series at least, go over the next principle in Solid, which is the open-closed principle. So stay tuned for that. Make sure you subscribe down below so you get that notification. Click the little bell icon to make sure you get notifications. And also, if you could just give me a thumbs up, I'd appreciate it. That helps boost this post on YouTube and lets other people know that it's here. All right. Thank you very much. And until next time, I am Tim Corey.